Okay, I'm going to take you through two examples of how to find probability using the sampling distribution of the sample proportion. We're going to find the probability using the normal distribution that we have used in previous sections, but now we have a new z-score equation because we're looking at proportions. So the first example says that the Texas Workforce Commission reported that the state unemployment rate in March 2007 was 4.3%. Find the probability that a sample of 250 people will have an unemployment rate of less than 3%. So the unemployment rate in March 2007 was 4.3%. Find the probability a sample of 250 people will have an unemployment rate of less than 3%. So over on the side, I'm going to write down P N. I've been given P hat in this case because I was given less than 3%. And those are all the numbers I've been given. So our P is 0.043. That was the overall unemployment rate. Our sample size is 250. And then the sample proportion that we're interested in is 3%, so 0.03. So following our normal distribution steps, which we should check and make sure that this is a normal distribution if we haven't already. This is the same scenario we worked with in a previous video, so I can say with confidence that I know that this is normally distributed. If you didn't know that it was normally distributed, you would want to go ahead and do the normality check really quickly. So our z-score, that formula is z equals p hat minus p divided by the square root of p times 1 minus p divided by n. Notice the only place that has p hat is at the very beginning. All the other p's are p, not p hat. There's only one place that p hat goes in this formula, and it's at the very beginning. So p hat is 0.03 minus 0.043 divided by the square root of 0.043 times 1 minus 0.043 over 250. Bring that over, extend this line. So 0.03 minus 0.043 is negative 0.013. And then the bottom square root 0.043 times 1 minus 0.043 divided by 250 is 0.012829809. We want to keep all those decimals as we're calculating the z-score. We don't want to do any rounding. So negative 0.013 divided by that really long decimal, negative 1.013. So that's our z-score. And then the rest of the steps are the same as they would be if this were a single x value or a sample mean. Step 2 is to draw our curve and label our z-score. So there's my curve. There's 0 for the z-score of the mean. we're at negative 1.013, so that's our z-score. Our shading, we want less than, so we're going to shade everything to the left of our z-score. So that's this area here. And then finally, step 4, we go into Excel and we do equals norm.s.dist because we're finding the probability, negative 1.013, comma, true. Yeah. And let me pull that up real quick. Yep, let me pull that up. I haven't done this one yet, so let's just do that real quick together. Equals, nope, my keyboard is not connected. There we go. Show keyboard. Equals norm.s.dist negative 1.013, comma, true. 0.15555. 555. So about 15.5% is the probability that you would find an unemployment rate of less than 3% if you took a sample of 250 people. So let's look at another example. So same overarching example. The state unemployment rate in March 2007 was 4.3%. We're going to find the probability that a survey of 250 people will find more than 15 people are unemployed. So now over off on the side, I have P is my 0.043. That's the proportion for the population. I have N is 250 people. But now this 15 is not P hat, it is X. It is the number of people that are unemployed. So I don't have P hat. I need to find P hat so I can use it in my z-score equation. So before I can do step 1, I need to do step 0, like a little pre-step of finding P hat. So P hat is X over N. X is the number of unemployed persons over my sample size. So 15 divided by 250 is 0.06. So 6% is our P hat. So what's the probability that we find more than 6% of people are unemployed? So now I can jump into my z-score equation. So z equals 0.06 minus 0.043 divided by, now my P and my N are the same as the previous problem that I did up here. So my denominator would be the same. So I don't need to recalculate that. I'm just going to write down the number again, 0.012829809. If my sample size had changed, then I would need to recalculate this. But I'm still sampling 250 people, So this bottom number, the standard deviation, is not going to change. So 0.06 minus 0.043 is 0.017, and then that's divided by 0.012829809. 1.325. Step 2 is to draw my curve. That one's just a little lopsided, but that's okay. Not looking for perfection. So 1 standard deviation plus a little bit more. We're just kind of eyeballing this since we don't have our actual tick marks to show us 1, 2, and 3 standard deviations. And then step 3 is to shade the area we're looking for. So more than means we want to shade everything to the right. And then step 4 is using Excel to find the probability. Since this is more than, I have to do 1 minus norm.s.dist 1.325, comma, true. And I do have this one available. 0.0926. So roughly a 9% probability that you would find more than 15 unemployed people in a sample of 250. And that is how you use the sample proportion distribution to calculate probability.